Let's start our course of network security. It's lecture number 4 on a model for network security. Under this topic, we will cover why this model is required, important terms which need to be discussed before understanding the model, what are the basic components which must be there in order to make a secure model, and then network access security, that how this access will be provided. So let's start with why network security model is required. Let me just put it down. So when an opponent possesses a threat to confidentiality, integrity, availability, or authenticity, this model is required. Means that if you deploy this model, unauthorized user will not be able to get your information over the network. So confidence, we have discussed these terms in our class, but for the sake of understanding, I am explain them briefly. Confidentiality, authorized user have access to the information only. Integrity, no changes are made by unauthorized user over the network when it is received by the recipient. Availability, data must be available to authorized user. Authenticity, authorized user is verified before access is granted. So now these are the terms which are need to be explained before understanding the model. Plain text, actually this is the information which you want to send to the receiver. We call it as a plain text or information. Ciphertext, this is in non-readable form. We convert our information in that form which is not understandable to unauthorized or malicious user. The process of converting the plain text to ciphertext, this is called encryption. And the reverse of this is called decryption. Means from the ciphertext to plain text, this process is called decryption. Cryptography means, crypto means secret and graphy means writing. So secret writing, actually you may call it as a ciphertext. When we convert from plain text to ciphertext, we call it as a cryptography. Cryptoanalysis is the art of deciphering cipher without knowing the key. Actually, this is the study which is done by the unauthorized users to get your ciphered information over the network. This is the key through which your data is, your data or information is made secure. Now, what are the components which must be there to make a secure model? A secure related transformation means an algorithm which convert your plain text to that form, which we call it as a cipher form, which is not understandable to your unauthorized user. We call this process as encryption, and this is actually mean of a secure related transformation. Secret information shared between sender and receiver. So there must be a secret information which must be negotiated between sender and receiver before the communication is started. So normally they are shared a key through which that information will be again decrypted, or this information will be encrypted at the receiver side. And who will share these secret key information? This is shared by a third party. Now this is a model. Let me have a marker or a spotlight. You see, sender wants to send the message to the recipient. So here we have plain text, and here is that mechanism which converts the information to the form which is not understandable to the unauthorized or an opponent here. So this is the secret information, means a key which is normally provided by a third party to the receiver to perform the process of encryption and convert the message into secure form or a cipher form. And then this message will be sent over the network, private or a public network. So this, when it received at the receiver side, this secure message is again converted into plain text by using the same algorithm which we deployed at encryption side for uh, to uh, to not available our information to unauthorized user. And we have the same key here, which is provided by the third party for the decryption of this ciphertext to plain text. And this is the third party which provides a key to both sender and receiver. This is negotiated in the beginning, that this type of key will be used between these two bodies, like sender or receiver. So sender will use this key for encryption, and recipient will use this key for decryption. Let me have an example. For example, if the sender wants to send information hello to the recipient, but this will not be sent as hello to the recipient, because because over the network we may have an opponent or or unauthorized user which can get your information. So we send it here like this is the information which will be sent over the network. So if the unauthorized user or opponent get this information, he will not able to understand that what it actually means. So when it received at the receiver side, this encrypted message will be decrypted and converted into plain text, which will be understandable to the receiver. So let me clear all this stuff. Uh, let me clear this. All right. So now, using this model requires us to design a suitable algorithm for security transformation. As I mentioned in the diagram, that you need an algorithm which normally convert that plain text to that form which is not understandable to unauthorized or opponent. Generate secret key. Normally, this key is provided by provided by a third party, and using that key, we convert our plain text to ciphertext. Develop method to distribute, and definitely there must be a negotiation between a sender and receiver before actual communication is started, that how the information will be encrypted and how the information will be decrypted on receiver side. So this will be negotiated in the beginning, and moreover how it will be shared, how this secret key will be shared, because if this key is accessed by unauthorized or an opponent, he can get your information and he can harm your system. Specify a protocol enabling the principal to use transformation, and definitely you need a secure protocol here for the negotiation between the sender and receiver, like you have a TCP or UDP type of a protocol or a secure protocol here for to start your negotiation. Now this is how let me have a marker again. Uh, for example, if an opponent get the access to the channel he will have to pass through the gatekeeper. You may call this is the gatekeeper, or you technically you may call it as a firewall or a router. It will be here, and uh, after authenticated, he will be allowed to get the access to the information system where all the resources you have will be available, and he will be provided after authenticated. So your gatekeeper must be here. This is the responsibility of the gatekeeper to to verify whether this user is a true user or a malicious user. So human or a software, if it comes to the gatekeeper, he denied the access to to information system. Let me clear all these designs. And now, using this model requires us to select appropriate gatekeeper functions to identify user. Definitely, you have to specify SOP or a protocol here that which user will be called a true user or authentic user, and which user will be called malicious user. Implement security control to ensure only authorized user access designated information resources. This is very true that once it passed through the gatekeeper after providing his information and after authenticated, he will be allowed to get the access to the resources. Trusted computer can be used to implement this model. Definitely, you must have a trusted computer there. Otherwise, he or intruder or opponent can harm your system. Uh, this is the end of our this discussion of security model. These are the books which we had discussed in our class. You can use any of the books, and using that book, you can actually complete your course contents in that. In the next class, we will be discussing symmetric encryption and message confidentiality. For uh, for that time, take care. Thank you. Allah Hafiz. Assalamu alaikum.